Okay, so before we start talking again about inheritance, first, is the final project going okay? Almost done? Oh, cool, okay. A lot of people, TAs have been telling me that a lot of progress, really great progress has been made. I'm excited to start looking over all of your code bases. All the TAs and me, we have organized all of your final project repos into a nice Excel spreadsheet. So I will be going through each of your code bases, and I may kind of poke in and leave like an issue or a little comment occasionally. So make sure that your code bases are very well organized. Definitely by the first checkoff. In the final project description, I believe I include a list of a bunch of kind of like best organizational practices. I don't think I'll pull it up this second, but does anyone remember, like, what are some kind of basic things that, like some basic requirements that are required of you in addition to just getting Hello World 1, 2, and 3 done? Like, what other things do you need to make sure that your code base is following? I don't remember. So maybe one thing is just getting like Clang format running on everything so that the formatting is all good. What's something else that's required? So it's no longer just your team looking at the code base now. Now it's going to be the TAs and me looking at it. So what do you need to do in order to make it readable for us beyond just like Clang format? Yeah? Documentation? Sure. Okay. I don't know if I necessarily need like full documentation in like a README or anything. You could add some, but I like where you're going. What can your code do to not really require documentation, but just how can you structure your code? Like what things can you look at in your code? Yes, in the back. Yeah, naming, that's kind of the most important thing. All of your variable names should make perfect sense. So if you are grabbing in the like data address or like maybe the load data address, maybe you should call that load data address or something. And then maybe something else, maybe it's like the program data address, maybe call that the program data address. A bad thing would be like, oh, you call one like a load data address, and then the next one you call like the address of program data or something. So it's like kind of scrambled. It's like keeping everything consistent and readable is very important. Capitalization of things. Yeah, kind of just small things like that. Someone mentioned comments. Actually, comments are generally considered bad practice in coding. Ooh, kind of, you've probably heard like, what? Like that's crazy. Like usually you want to comment your code like heavily. Actually, leaving comments, so comments in a way, they are actually code in and of themselves. Like when I write a big like comment block, now someone will need to make sure that they keep that comment up to date. They will need to like debug comments. It may be that someone updates a function later on but doesn't update the comments along with it. Now when someone goes in and tries to understand the function, now they're going to think that there's a bug in your function. They're going to spend a lot of time looking at it because you have all these comments that maybe were not like updated. And what is the big problem with comments versus code? Like, why is it okay to like change? I can't think of a good leading question. I guess what I'm trying to get at is with code, you can write a test for it, and you can test if your code is working. You can add extra tests to check new functionality. You can't really add tests for comments yet. Like in theory, maybe in a few years, like someone will release this great like LLM package that will actually verify that all the comments are correct in your code and will give out like warnings. But there's really no actual way to make sure that your comments are like well worded or actually correct. And so actually in a way, it's good to just not have basically any comments in your code. And instead, just write very clear code from the start. Write code with really strong variable names, really strong function names, and write your code in a way that is self-documenting. So if you have like just data passing from one class to another, clearly labeling what the data is like in the variable name and within the class members. Yeah, so that is arguably more important than comments. And actually, we will dock you points if you have a bunch of comments in your code. Because what that means, if you have to write a bunch of comments, probably means that your code was not written very well. If you need someone to sit there and explain your code to you, probably means that you could structure your code in a better way that's more intuitive. Yeah, question?
I don't know if I fully agree. Like, I believe that like having too much comments is not necessary, but sometimes it can explain the design decisions of why you did one thing versus another. Because then someone might look at a code and say, oh, I think I can do it this way, because I don't like this implementation. But at least if you understand why they implemented a certain way with this comment, then it can help.
I actually completely agree with that. Yes, so a great reason to actually include a comment on something is, yes, on a specific implementation detail that maybe is not obvious by just looking at the code. And that is the most useful reason for having a comment, is maybe you are calling, honestly, maybe you're calling an API that the API itself is very confusing, maybe has poor documentation or has just bad function names. And so including comments as like kind of a wrapper around some like API, that would be great. Or maybe you are implementing a really confusing algorithm. You can add a little comment to like a Wikipedia article of that algorithm that you are implementing, so people can know like why are there weird like pointers or things being used? It's like, oh, they can now read about it in some Wikipedia article or something. Another comment.
Also, if you're working like on a big project and you're trying to get like a new employee to come in and like look at the code, like having comments is also really useful for just like kind of fully understanding going through step by step.
Yes and no, because like I said, like comments can have bugs. So the comment that was brought up is having comments in code can be useful for onboarding new people, because now there's explanations of things. That's only true if your team is large enough. If you have a dedicated person that their job is writing comments and you have someone who's maintaining all those comments, oftentimes you're not going to have that. Oftentimes it's better to just write code that is clear from the start so that you can test that code. And so now when someone comes, like is onboarded, instead, they can just look at the code and read through it and understand it better, versus now trying to understand, it's like, okay, are the comments even correct? It doesn't look like the comments are actually saying like what is true here. So it depends on the size of your team. It depends on your funding. A lot of like software engineer jobs are funding is being cut. So I would argue in the modern day, comments are becoming less and less important, because now you just want the code you would rather the code worked. And what am I saying? You are more likely to have bugs in comments nowadays because there are fewer software engineers than there were like 10 years ago. This is something that I've seen. And it's possible maybe other people have seen different, but in like 90% of code projects that I've seen, comments are used less and less in the modern day. Anyways, okay, sure, good. Another thing that I wanted to chat about, like I said, function names, variable names, few comments, those are important. Another thing that is probably important is it is to remove the use of magic numbers from your code. Does anyone know what a magic number is in software? Yeah.
It's just a number that's just sitting in the middle of code.
Yeah. Right. So oftentimes you'll be writing a function and maybe you just need like the number like 30 because maybe it is a constant value in some like physics equation or something. So, I'll just throw this in there. You just boom, type in 30 and move on. And now when someone comes along and tries looking at your code, it's like, wait, why did they throw in 30? And you could add a little comment or something. You could say like, oh, like 30 represents like the number of atoms in like this thing or something. But instead, a much better thing to do would be to use either like another like variable to like hard code, like a constant at the top. You can also use something called an enum. Has anyone heard of an enum before? Yeah, cool. So I'm going to quickly give you a little demo on enums. So enums are great when you are using a bunch of integers that are all like semi-related and all kind of fall under the same kind of data type. For example, opcodes. So what you probably have in all of your implementations is you'll have like, 30, how many opcodes do we have? Maybe like 16 opcodes or so in the Banana Slug project. So you have about like 16 opcodes, and what you could do is just like hard code each one of those opcodes, like, oh, if opcode equals like 10, if opcode equals 13, if opcode equals this. But a better way to do it would maybe be to use this type of data type. So this is an enum, and so it's kind of structured in the same way as a class, where you, instead of saying class, you write enum, then you put the type name, so you put day, and then instead of all the members, then you list names of numbers. So it's like enumeration, so it's assigning names to numbers. So here, if I hover over Monday, you can see it's assigning it to the value 0. Hover over Tuesday, it's assigning the number 1. And so now I have all of these like keywords that I've just created in this C++ project. And now anytime that I need to like encode the day of the week, instead of using an entire string, now I can just use this keyword. And so it's much better in terms of memory, because yeah, if I wanted to store like what day of the week it is, I don't want to store like this big long like Wednesday string. Like that would be several bytes. Instead, I can just store it as a single integer. And the integer will be 2. But I can still use this like keyword as if it's Wednesday. So here, I have this function down here. Let me zoom out a little. Yeah, so we can see, so here's a switch statement. So you could imagine this is probably similar to how you would want to do your opcode decoding, possibly. You could also use a big array if you want. But yeah, so here I am passing in this day enum that I've created up here. And then I switch depending on the integer value. So I say, okay, so if day equals the value 0, then convert this into a string, where I convert this like keyword into this string. And so I have get day name. And the whole purpose of this is we can see down here in my main, when I get today, maybe I should change this to Wednesday instead. Wednesday, okay. When I say today is Wednesday, then now it will go and convert from this integer value into a string. So that's what this function does, is it happens to convert this integer that we've created into a string. Yeah, let me quickly run this. Maybe that'd be helpful. No. Okay. Okay, so yeah, there we go. So you can see it says today is Wednesday. That's because I'm passing it into this function. Okay, wait, really quick, turn to your partner. What would be printed out if I now had it run this instead? So I'm removing this function name. I'm getting rid of this function call, get day name. Instead, now I'm just printing out today, which is a type day. Okay, turn to the person next to you. What would now be printed out? Okay, I'm going to run it. We'll see if you're correct. Okay. Yes, question. Yes, actually, yes, I think so. Yes, yeah. Mm-hmm. Yeah, question? Yes, I'd be happy to. Let me zoom out a hair as well. So Monday starts at 0. So it, by default, it maps it to an integer. And I believe we can actually specify what data type we want to map to. If we wanted, we could map it to an unsigned integer. I think it would be here. We could say uint8t. Is this going to work? Maybe it has to be on the other side. Now I don't remember how to do it. Anyone remember the content? Yeah? Is it like this? Okay, cool, yeah, thank you, cool. So if you wanted, yeah, you could hard code the value like this. And yeah, I guess it shows up even says like one U, meaning unsigned. Yeah, well, this is great, right? Because now, instead of storing this large string, now it's just an integer, and that's going to be way less memory usage, and it's going to be faster than using like a full string. So, yeah, cool. Yes, question?
If it like works by, what's the point of having like the day part? Like why assign it to today? Like using day.
Oh, yeah. You don't need this, but maybe you had like an opcode where you needed to fetch the opcode out. Opcode equals 0 something, and then maybe you said like opcode is equal to like something else, or maybe you need to shift things, and it took a while. Like maybe it took multiple steps. Maybe it's just nice to have it in this sort of structure. You could also probably just do like int today, int, and you could say like Wednesday. You might just have to cast it to an int, but it would still work. Yeah. So I guess it just depends on your use case. But yeah, you don't need this. Yeah. Okay. So cool. Now, is anyone already using opcodes? Sorry, anyone already using enums for their like opcodes or function codes? Okay. We have one single person. Okay. Quickly chat with the person next to you. How would you like brainstorm now? How could you slightly modify your code or use enums now to simplify the process of checking whether an instruction is using a certain opcode? Yeah, okay. So go and chat with the person next to you. How would you use enums to simplify your code? Okay, so I'm going to kind of go through what I was thinking. Maybe it's going to be similar for you. So what I was kind of thinking is maybe we can have an enum of like opcode, right? And then maybe we can have different opcodes appearing now. So maybe we have like the, trying to think, shout out an instruction that uses an opcode. What was that? Yeah, I think JAL. Okay, maybe that has the opcode. Oh, by the way, we can add an equal sign, and we can like hard code the actual value that the enum takes on. So here, like you can see, it's like 0, 1, 2, 3. If we wanted, we could actually just add a little equals somewhere, and we could say like, oh, this now equals like 8. And if we now do that, then Tuesday will now equal 8. And actually, then afterwards, then it will start counting up sequentially after what we just did. So Tuesday's 8. So then Wednesday is now 9, Thursday is 10. Monday will start at 0, so the first element always starts at 0. But if we want, we could now set this to like 4 or something. So now Monday before Tuesday 8. There we go. So we could probably do something similar where maybe jump in link is going to be opcode 4. And then maybe we have another instruction that is like and maybe this is, I guess that's an R type, so maybe we'll do or I. Maybe this has an opcode of like 7. And we can go through all of the different possible opcodes, right? And then we can somehow write some function to, instead of converting the enum into a string, maybe instead we convert this opcode into the specific instruction to run now. Cool. Is that what other people were thinking? Anyone think anything different? Okay. Okay, cool. Enums, yeah, I love them. Use them all the time. One of the best things about them is, yeah, it helps you save memory. So actually, as a chip designer, personally, like I use enums all the time when I'm writing system Verilog. If anyone has written system Verilog, like that's honestly the main use case of enums in my personal life. So that's why I felt like it was important to talk about enums, because I do this all the time. Yeah. Okay, cool. So let's return to inheritance for a bit. So we're going to spend the rest of class talking about inheritance. First, we'll start with some terms that we covered on Monday. Then we will move on to a bunch of reasons why when inheritance fails, and why inheritance is not always the best. So, okay, quick. What is inheritance? Inheritance. Yeah.
Jokingly referred to as base class legal. It is a way for like classes to be something also represented as something more basic.
Sure, okay. So I like to think of inheritance as, yeah, it's when you have a child class that will receive members, like function members and variables from sort of some parent class. So when a child receives, members from a parent class. Okay. What is a parent class? What is a base class? So parent class and base class, these are synonymous with each other. So I guess it's kind of in the name. So a parent or base class, this is the class that is inherited from. Okay. Well, then what is a child or derived class? Okay, what is the definition? Child or derived? Yeah.
A child class is a class that inherits from the parent.
There we go. Okay, cool. So a class that inherits from parent. Okay. Now what is a virtual function? Yeah?
A virtual function is a function that is, trying to think of the right words. It basically, if there's no other function, it will be the function that you use. It's the backup function.
Backup function? Okay. I like that. So backup for what? Probably like an for an override function. All right. So yeah, so a virtual function is a function that can be overwritten by a child class. Maybe I'll do overridden. Okay, and an override function, this is a function that, like in a child class, that overrides the parent class. Okay, cool. What is now a pure virtual function? So slightly different from a virtual function. I'll tell you it's still a function that is overridden by a child class. What is the difference between just a regular virtual function and a pure virtual function? Do you remember? We spent like 1 minute on this. Oh, yes.
Children classes are forced to override.
That's exactly right. Yeah, so it's when a child is forced to override the parent function. So let me reword this. So it's when it's a parent function that the child is forced to override. Yeah. Okay. Cool. What is an abstract class? Yeah. Not quite. Close. I'm looking for something else. So abstract class, yes. Sure. These are both kind of correct. The real definition of an abstract class, it is a class that cannot be created, like it needs to have something override it. And specifically, the reason why it cannot be created is because it has a pure virtual function. So an abstract class is a class with at least one pure virtual function. And because it has a pure virtual function, pure virtual functions have no implementation. So therefore, an abstract class cannot be created because there is no implementation. Cannot be created. Yeah. Okay. So in order to use an abstract class, yeah, the idea is you inherit from the abstract class, then you implement all of the what? When you inherit from an abstract class, you need to implement what? Close. The pure virtual functions. Yeah, you need to override the pure virtual functions. Okay, cool. Okay, I don't think we mentioned what an interface was. We will talk about interfaces today, though, but an interface is a class with only pure virtual functions. Okay? Polymorphism. Okay, kind of a loaded word. Anyone have a good definition of polymorphism? That's our final term. Okay, I'll tell you right now. So polymorphism, it is the ability for an object to like maintain its functionality even when it's casted to another object. So if you think like if you have a, for example, like last time we had a square class that inherited from the polygon class. Sorry, yes, it inherited from the polygon class. And then when we casted the square class to the polygon class, it still was acting like the square class. So when we casted it to the polygon class, it was still acting like the square class. So when an object maintains its functionality even when casted to another type. I'll just say when casted to another type. Okay, cool, good. So we're going to add a couple more things to this list as we get deeper into inheritance. Like I've said, inheritance is not the most popular coding paradigm nowadays, and we're going to kind of look at why. Yeah, oftentimes inheritance is not the best. Cool. Okay, so we made 3 classes on Monday. Do we remember what the 3 classes are? I've already kind of mentioned them, but yeah, what were the 3 classes? Yeah.
Polygon, rectangle, square.
Yeah, cool. Okay, so we had polygon, rectangle, and square. So polygon, rectangle, square. Right? And the idea with each one of these classes is the rectangle got all of its members from polygon, and then square got all of its members from rectangle. So we had this structure of inheritance. Cool. And this is really beautiful. This is awesome. This means that our square class was able to be very small, didn't have to reuse any code. What does it mean? What is the acronym that we call code when you can reuse a lot of code? Yeah, what is that acronym called when you can reuse a lot of code? Yeah, it's considered dry code. Dry meaning don't repeat yourself. Yeah, that's kind of the whole purpose of inheritance here. Okay, cool. Now let's say we come along and your boss comes up to you and says, hey, like can you just add on to this? Can you now make a right triangle class? Okay, so right triangle. Okay, so we have a right triangle class. Where should this inherit from? Should it inherit from square? Probably not. Okay, yeah, so which class should it inherit from? Yeah, probably just polygon. Yeah, I don't think we can really do anything too kind of fancy here. Let me just kind of refactor this a little bit. Okay, cool. So good. Right polygon. Sorry, right tri inherits from polygon. The idea with this is that like a right triangle is a polygon, so therefore it like obtains all of its members from polygon. Versus a rectangle is not. A right triangle is not a rectangle, so we would not inherit from rectangle. Okay, cool. So now, let's say your boss comes up to you and asks you to make an equilateral triangle class. Okay, so should this inherit from right triangle? Probably not, right? Because right triangle, an equilateral triangle can never be a right triangle. So instead, we should probably just inherit from polygon. Okay, cool. Well, now let's say they ask for a scalene triangle class. Okay, well, can a right triangle be a scalene triangle? Actually, I think you can't. So scalene triangle definition, anyone? Yeah?
Triangle with sides of 3 different lengths.
Yeah, perfect.
Yes, a right triangle can't be.
Yeah, thank you so much. Yeah, so a scalene triangle, all 3 different lengths. So yeah, we could have any sort of right triangle. All 3 of these lengths are different. Therefore, this is a scalene triangle. Okay. So if we have a scalene triangle, should this inherit from right triangle? Not necessarily, because we can still have a right triangle that's not a scalene triangle. Okay. So it's good. Maybe this is an important kind of blackboard moment. Maybe you're sitting there with your boss and all of the people below you. You're managing this team of software engineers. You're trying to just brainstorm how to organize this large inheritance project, object-oriented design thing. And you're on the blackboard. It's covered and all this sorts of things. Maybe you have like 20 classes and you're really excited. And finally, this is your result. Is you realize, okay, now it's time. I'm going to implement all of these classes, and they'll all go and inherit from one another. Yeah, and this is great. Then maybe someone comes along and is like, oh, let's add a triangle class now. It's like, triangle class, but what I could do, I could just do try and then point that there. But now I'm probably going to have repeated code. So maybe I don't want to have this, and instead now I want to refactor everything. And so what would that refactor look like? How would I rearrange these arrows to now inherit from this triangle class? Yeah. Right, yeah, exactly. So each one of these 3 classes would now inherit from triangle. And in this small case, there's only 3 classes. It's not a big deal. But now let's assume that maybe you had a few hundred classes. Maybe this is an extremely mature project. People have been working on this for years, and now someone has asked you to make, what now in hindsight is a very trivial sort of addition, but maybe you didn't quite realize that you would need this triangle class at the time. So now you have to do this actually extremely expensive refactor, because now every single class here, equilateral triangle, scalene triangle, right triangle, they all need to almost be completely rewritten from the ground up to now inherit from triangle. And if you don't do that, then you're just going to keep having more and more clutter, and you're going to get further and further away from don't repeat yourself. But also, now when you go and do it this way, then now there's coupling, and it's just very tricky to now make changes. This one tiny little change, this one change to add this triangle class now caused you to edit maybe 1,000 lines of code for this. So that is a huge kind of downside of object-oriented programming. So keep this in mind. This is a basic kind of interview question. It's what is a downside of object-oriented programming. The issue is refactors are extremely expensive and also somewhat common. Like if you need to just add one little bit of functionality, you might need to edit several children classes. Yeah. So this is kind of a pain. Okay, so let's move on from that example. I have prepared a little bit more code. Okay. Ponder this in your mind. We'll come back to this. Okay, so here is our triangle, rectangle, our square, rectangle, polygon classes. Good. I've published all of these code files. These are all from Monday, and I published these all on Canvas, so you all should have access to them. But let's assume now that maybe you've spent a lot of time, maybe like 10 years, building out this great Polygon framework. And now when someone comes along and maybe they need some sort of Polygon class, maybe yours is the first thing that's on GitHub, and they're really excited, so they go and pull it in. They're using CMake, it works really well. And maybe this person is a general contractor who builds fences. That is their business. They're hardworking person, and they make fences, but they also enjoy coding. And so they're like, you know what, I'm going to actually use this person's Polygon library, and I'm now going to create like a fence class that will help me keep track of all my customers. So I'll create a fence class, and so maybe we'll say fence, and I will actually maybe all of my fences are going to be square, so therefore I will inherit from square. Yes, is there a question?
Just in the Polygon, I think you might accidentally
Thank you very much. Okay, cool. So in fence, so in fence, I will now inherit from square. So remember, in order to inherit, you do the single colon, and then we'll just do public square. Oops. Okay, and then, so what this will give us, I need to just include square now. Okay, and now inside of this, I have access to everything inside of square. So I have access to this, I have access to all of the points, and I have access to everything inside of rectangle and polygon. So you can see I can ask for the area, the perimeter, and I can create an SVG, and this is great. And maybe, I want to add on a little bit extra functionality. So maybe I will now add on maybe like std string, like paint color. And then maybe I'll do std, I don't know, we'll do double post height. Okay, sure. Makes sense, right? Cool. So this is good, this general contractor, super excited. Now this is their fence class, and it's really successful and really great. But then maybe they notice, this library that has been updated for many years actually just had a new update, and so now I'm going to pull in all of these changes, and let's see what happens. So first, actually I'm going to create a main function. We'll just try running some of this. So I can create a fence. F, it's fine. I don't need that. Turn 0. I will just get rid of this right here. Okay. Good. It is what? Okay. I guess I just need to add a constructor really quick. Okay, so adding a constructor, so I will make this public and fence. And we'll just do a default constructor. Then we will need to call the square constructor. So in order to call the square constructor, I will use an initializer list. So adding this colon, and then I need to pass in everything inside of the square constructor. So here you can see it takes in top left, so we'll just do 0, 0. Then we need a height, and that's it. Okay, good. So that should be good. Okay, why are you still giving me an issue? I don't know. Okay, so let's compile this now. So in CMake lists, I will now change this. Instead, I will be fence.cpp. Build CMake ... So now I'm calling CMake from my build directory, so it's building me all of the make files. And then I can do make. How do I run make multi-threaded? -J, yep. And then I can specify the number of cores. If you want, there's this cool program that comes with Linux called nproc. So if I hit enter, it shows the number of processors, the number of logical cores on my machine. So it says 22. So what I can do, if I want, is I could say make -J, and then I can, in place, put backtick for running nproc before actually executing the instruction. So what this will do is it will elaborate out to make -J 22. So if I now run this, then there we go. So it's now using all 22 of my threads. Okay, what's going on? Oh, this should be int. Hopefully that fixes it. Good, fantastic. Okay, so yeah, cool. So what you may be concerned about if you are the general contractor, maybe every time that there's an update, you just want to make sure that there's no additional memory being created, because maybe your machine is really memory limited. So I will do cout, and we can print out actually the size in memory that our fence object takes up. Does anyone know how we can print the size of an object? Anyone know the keyword for that? Size of, yeah, thank you. It'll be size of, okay? And then we can put, we can put an F. Okay, and that actually might work. Okay. Oh, wait, I think it'll be shapes. Sorry, shapes. Okay, there we go. So it looks like the size is currently 72. And I think that that's probably correct. Let's quickly double check the other sizes though. So if I check the size of polygon, polygon, okay. Then I can check the size of rectangle as well. And I can check the size of square. And then the size of fence. So notice, so polygon, all it has is a single vector of points. So this, I'll tell you, I believe this is going to be 24, is that right? Actually, okay, I can't remember the exact size of this, but we'll find out. But it's going to be the size of this. And then the rectangle, how many members does this have? What is the additional size that rectangle will add to polygon? Does this have any member variables? This has no additional memory variables, so therefore the size of rectangle, should it be greater than the size of polygon? I think it will be the same size as polygon, because rectangle does not have int I or something. If it had an additional member variable, then it would accumulate. And then square, if you notice, so square also does not have any member variables. So therefore, both rectangle and square should be the same size as polygon. So let's now run this. There we go. Okay, so we see that all of them are the same size. They're all 32 bytes, and that is just due to that vector. And if I now print out fence, if you remember, I think it said 72, and that is because now I'm including this string here and then also this double right here. So all of that combined in total, we can see that it's 72 bytes. Yeah, cool. But now, if we get an update, if Polygon gets an update, so if we go into Polygon, and maybe now Polygon has like std string color or something. Or maybe it also has like std string, I don't know, name for some reason. We could add like a bunch of other things inside of this base class. And what will that do to the size of polygon, rectangle, square, and fence? Yeah, it'll make it go up, right? So if I now rerun this, then now instead of it saying 32, 32, 32, 72, now we can see that it's way higher. And this is like quite annoying, right? Like if you are just using this random library and maybe you've been using it for many years and then all of a sudden someone goes and adds all this extra functionality to you, that means that the child classes are now forced to have all of this memory. Like they can't choose. They can't be like, oh, I don't really want color or name. Like I don't want to use this. Well, it's too bad because no matter what, like if the child has it, you will inherit from it. Yeah. Yeah.
So, like, what about different, like the vector itself?
Mm-hmm.
Like, you have different sizes, right? So does that not affect the memory, like, especially for the fence class? Because you're looking at the size of, if you look at the size of fence after it's created,
Yeah.
it can be like much. Correct. If you have two different, let's say, polygons, like one of them is only like 2 points,
Mm-hmm.
one is it going to be a greater size?
So it actually won't because vectors will allocate memory on the heap. All right, yeah, so yes. I guess the main point is when the general contractor was using the square class, they were aware of the points, and they were happy with the points. They thought that implementation was good. The issue is when square was secretly updated, or a child class way down, a base class way down the hierarchy, that was updated without any sort of mention. So that's the issue, is the base class now forced the general contractor who doesn't really care about the extra name and color strings. He doesn't care about them, but they were still added into the fence class. So that was the additional memory that he wasn't happy about. Yeah?
I just mean generally using size of.
Sure.
That only gets the size of the data on the stack.
Yes, exactly. It gets the size, yes, it's the size of the memory, excluding any pointer. It's the size of all the primitives, I guess. Yeah. Yeah, good question. Sure. Cool. So, sorry, trying to get back to where I was trying to remember. Okay, cool. So so that is kind of a downside of of inheritance, is that the base class will now force upon all of the children any additional members that you create. So it's generally best to keep all of your base classes as small as possible. That's another important design consideration. Keep your base classes as small as possible. Okay, but now maybe another thing is maybe later on there's another update. And and this update doesn't just waste your memory, but maybe now it wastes the time of the developers, because now maybe they've added a pure virtual function. So maybe they add a print method. This is totally reasonable. So virtual void print equals 0. Okay, and this is going to be an issue because if I try to compile this, what do you think we'll say? Okay, so it's not happy with this. What does this error say right here? So so fence has now turned into what type? Yeah, fence is now abstract. And if you remember, abstract classes cannot exist. you must override that function. And so now this fence, it's like, like I didn't need a print method. It's like, why did you just add this print method out of nowhere? Like I don't need this. So like, okay, fine. I guess I'll spend like an evening one night. I'll go in and I will override that, and I will say like void print, and I'll override it, and it'll be kind of dumb. I'll just do that. And that'll be fine, sure. So I overrode it with nothing, but maybe that took like an hour to like figure out like why my code wasn't compiling or something. But sure, there we go. So it should compile now because now I have overridden this. Okay. So those are kind of two reasons for why we would want to keep our polygon class, our like base class, as small as possible. Is we don't really want to add on any additional members because now we'll create unnecessary memory. We also don't want to just throw on unnecessary pure virtual functions because that now forces the whoever is using this class to now implement all of these methods. Maybe we don't actually need all these methods. Instead, a much better way to go about this is actually to just create a whole nother class that we inherit from. So for example, like for the string color, maybe what we could do is instead we could have a class like colored polygon or something. Maybe all that is inside of this is just string color. And then maybe we have something like some sort of like void, yeah, sure, I don't know, print or something. And maybe this is like where we put our pure virtual function. I'll actually leave this off. But anyways, this is kind of a weird looking class, right? All it has is just a single string. But actually, what you'll find is this is a totally reasonable type of class to have when dealing with object-oriented design. Because it's extremely small, meaning that you aren't burdened by any additional features. Like if someone else wanted to come along and add like a name, they probably wouldn't add it to the colored polygon class. Instead, they would probably create like a named polygon class or something. And now the user wouldn't be forced to use this colored polygon class, but maybe they would want to. So maybe the fence class, it inherits from square, but maybe it also now inherits from colored polygon. Sorry, and let me make this public really quick. Public, yeah. So then maybe now this paint color that I have right here, you know what? Maybe actually I'll remove this because now maybe this colored polygon class maybe has extra functionality that I might end up liking. So now I can come in and I could print out like the color using this colored polygon thing. Or maybe a different general contractor might decide, you know what, I actually don't need this colored polygon to be inherited from, so I'll just remove that. So it's totally up to like whoever is using the class. So yeah, keeping your classes as small as possible is extremely important with object-oriented programming. Yeah. Any thoughts or questions on this? Are these design decisions constraints that people have already seen before? Has anyone used inheritance in a project before? Just wondering. Okay, sure. Yeah, so in general, yeah, keeping your base classes small is important. Okay, yeah, any other kind of questions? I went a little bit faster than I was expecting. I don't think I had anything else kind of prepared for today, but I don't know. Oh, we could talk about the final project in case anyone needs help with anything on that. Yeah, question.
I was actually going to ask you personally, but I wanted to know what banana consoles do. I was thinking
Oh.
we'll just print out the hello world, for example, or like, is there any particular function you use for that?
So yeah, okay, good question. So just to double check. So does anyone have any questions on inheritance? If not, then yeah, there's some good discussions to be had in the last 5 minutes about the final project. Yeah, so there's a question.
I have a question about the pure virtual function.
Yeah.
So when a parent inherits the pure virtual function, each of its child, like every single child has itself.
The first, as soon as the function is implemented once in the hierarchy, then all of the next children will have that function implemented. Exactly. That's exactly right. Yes. So a pure virtual function has no implementation. And the second that it is implemented, then it will pass on that implementation to whatever the next child is. Yeah, great question. Another question.
You added like inheritance from two different objects.
Yes.
How does that like work? Does one take precedence over the other?
They just both happen at the same time. Yeah.
Like if there's two constructors and you
Mhm.
try to call the default on the fence.
Oh, yeah, great question. So if colored polygon had a constructor, like this. So colored polygon now has a constructor that doesn't do anything. We can call this constructor just by going like this. Yeah. And I believe we can put this in any order. I believe like we could put colored polygon first if we wanted. Yeah, there's no precedence. No, I think maybe people would keep it in like alphabetical order for like preference. But yeah, good question. Another question.
Last week you had an example where there was like a top class, a tool, and a logger.
Yes.
Did tool and logger have to inherit from the top and then pass pointers to each other?
No. Yeah, so actually in the final project, I would recommend almost never using inheritance. On Friday, I will mention one tiny little way in case inheritance may be useful. Yeah, so for the console class, the idea with the console class is that you have one kind of top level class that has your CPU and your memory and everything. And each one of those subclasses, those are not related to inheritance in any way. Instead, they are encapsulated. And it's a common question of like when do you inherit versus when do you just have that object. And so the top class will have the objects like CPU, memory, and whatnot, and there's no sort of inheritance that happens. Instead, it just has that that member, and then the member actually has a reference back up to top in case that member needs to access any of top's members for any reason. Yeah. But yeah, the purpose of console is just to organize all of your classes into one place, and then maybe you have like console.load on your ROM file, and maybe that like loads in the file into memory, and then you have console.run, and maybe that executes your ROM file until you eventually get the stop syscall. Yeah. Okay. I could show what Hello World 3 looks like, in case anyone's interested in that. Yeah? No? Yeah. Okay. Cool. Yeah, anything else you'd like to see? I can show you like assembly or C one more time. Just quickly getting things set up. Sure, okay. I actually haven't looked at Hello World 3 in a little bit, but you're welcome to look at it as I pull up the build of it. Okay. Maybe go and chat with the person next to you about what this loop is doing. Okay, so this is Hello World 3 being run. So you can see that first it prints out to stdout, and this is done. So there are, depending on what frame I'm currently on, so you can see like a frame is a single iteration of loop. So when frame equals 0, then what it will do is it will print out all of the values inside of this stdout stir array, which is up here. So stdout stir array says hello stdout. Okay, so that's the first thing that happens. It says hello stdout. Then it will exit this if tree and then increment frame and then move on to the next loop iteration. And we'll check, okay, frame equals 1, so now it will now print out to std error. And this is at, a slightly different memory address. You can see that it's when I write to address 7120. So this will now print out to std error. Okay, and then on frame 3, it will run get name. So running a function will, in order to run a function, you will need to make sure that you have all of your registers working. You'll also need to make sure that your stack pointer is being set correctly. So in the stack pointer explanation in the documentation, there's a section that explains what you need to initialize your stack pointer to. So okay, so we can look at this get name function, and effectively what it does is it says it's just going to fetch out your name according to some max size, which is specified up here. So the maximum length that is allowed in this is 20. So I can't have my name be too long. So I can say my name is Ethan Sifferman. Okay, hit enter. So there we go. It says, hi, Ethan Sifferman. And it prints back with stdout. It prints back this data and then prints what my name entry was. And if I have my name be too long, so if I say like something like this, okay, here my name I assume is longer than 20 characters. So now if I hit enter, then it will condense it down. It won't actually print all of it. Instead, it will just print the first 20 characters. Now, yeah, question. Yes, and actually that is provided in the documentation, I believe. Where is it? Documentation. Yes, so the stack pointer register is mentioned right here. There we go. So you can see it looks like, so you will need to set it to the address of 0x5200, which is kind of an arbitrary spot of where the stack was chosen to start at. And what it mentions right here, where is it? Yeah, so right here it says, after completing the setup or loop functions, the stack pointer should return to its initial value. So this is the expected behavior. So what you should imagine is that after running the loop and setup function, you will see the stack pointer register. You'll see it like increment a bunch, then you'll see it decrement, maybe it'll increment again, it'll go up and down, up and down, up and down. Things will write to it several times, but by the time that it finally exits, once it exits, you should see it return back to this value. And that effectively means that the stack was properly cleared. Yeah, so that is the way that you would check if the stack pointer is set up correctly, is make sure that at the start when you enter the setup function, and at the start when you enter a loop, that at the end it will return back to this value. Yeah, cool. Any other questions? Good. Okay, we're a little over, so thank you all. We will return on Friday with more inheritance stuff, but reasons for why inheritance is actually useful. Today was kind of reasons why it can be bad, but on Friday it's going to be all the use cases that I have seen in the real world with inheritance. So, okay, cool. I will see you all on Friday.